Hi guys, welcome to my channel, Titostutor Your Math Pedagogue. In today's video, we're going to be talking about laws of indices. Indices is also known as exponentials, and there are different laws of indices that we use in solving problems in math. The first law we're going to be talking about today is multiplication law. In multiplication law, whenever two numbers that have indices are multiplying each other, you make sure that the bases are the same. In this example, there is x raised to the power of a multiplied by x raised to the power of b. So you can see x raised to the power of a multiplied by x raised to the power of b. X is the base and a is the power. The other one has x as a base and b as a power. So because the bases are both xx, you choose one of the base and add their power. So your answer becomes x raised to the power of a plus b. Now let's look at this example. It says simplify 10 raised to the power of 2 times 10 raised to the power of 3. You know that 10 and 10 are the same. The bases are the same. So all you need to do is choose one of the base and add their powers. 2 plus 3. And this gives you 10 raised to the power of 5. And you're done. First law of indices. Here's our second law of indices, and it is the division law. Again, we're using an illustration of x as the base raised to the power of a divided by x raised to the power of b. Again, the bases must be the same. X is the basis, is the same for the power of a and the same for the power of b. So choose one of it and subtract their powers in this case. Remember, our multiplication law was to add their powers when they are multiplying each other. But now, x raised to the power of a is dividing x raised to the power of b, so you subtract their powers. Let's take an example of 22 raised to the power of 7 divided by 22 raised to the power of 3. So because they are dividing each other, you pick one of the bases, which is 22. You have 7 minus 3 in this case, and it becomes 22 raised to the power of 4, and you are done. Because the bases are the same, you're dividing, just subtract the powers. 7 minus 3 is 4. Here's our third law of indices. It's called the zero index law. And it says anything raised to the power of 0 is 1. Anything whatsoever. So far, the power or the index, the exponential, is 0, then it is equal to 1. That's it, right? So the illustration here is still a base of x raised to the power of 0 is 1. And let's take this example. Remember our second law, which says when two numbers with powers of the same base are dividing each other, you pick one of the base and you subtract the powers. In this case, 10 raised to the power of 2 is dividing 10 raised to the power of 2. So the bases are the same, 10, 10. I'm going to choose one of it and subtract the power. 2 minus 2. Remember that 2 minus 2 is 0. Now I have an answer that says 10 raised to the power of 0. So I'm going to use the zero index law that says anything to the power of 0 is 1. And I am done. Here's our fourth law of indices, and it is the negative index law. Anytime you have an exponential, that is negative. The illustration here says x raised to the power of a negative a. So you take the reciprocal of x, which is 1 over x, right? So you have x raised to the power of negative a is the same as 1 over xa. If you notice, the negative disappears. Immediately you have 1 over x, the negative disappears. Let's take this example. 2 raised to the power of negative 2, okay? First things first, you note that there's a negative in your index. So you take the reciprocal of 2, which is 1 over 2. Your negative disappears and you're left with just raised to the power of 2. 2 raised to the power of 2 is the same as 2 times 2. And that gives you 1 over 4. And you are done. Negative index. Take a reciprocal of this, the negative disappears, and you have 1 over 2 raised to the power of 2, which is 1 over 4. The fifth law is product of index law. And this means that you have x raised to the power of a, and in brackets, b is powered outside the bracket. So it is x raised to the power of a bracket power of b. So this is product. You multiply these two. A multiplied by b, which is the same as x raised to the power of a b. Let's take an example. In this case, this example says 5 raised to the power of 2 in brackets to the power of 3. This is the same as 5 raised to the power of 2 times 3, which is 5 raised to the power of 6. And you are done. So we call this product of indices law. All right. If you're still watching till now, I want to say a big thank you to you for sticking by. Please don't forget to like this video, subscribe, share, and turn on notification so you don't miss any math video from me. Thank you. Here's our final law of indices, and it's known as fractional indices law. When your exponent, when your power is a fraction. But this law is divided into two. We have the index that has 1 as the numerator. Your power is a fraction and the numerator is 1. Then there's the other part where your fraction has a power bigger than 1. It isn't 1, it's something else, right? Okay, so if your power is 1, all you need to do is do a root of your denominator and your x. Can you see? The denominator is the root. If it's 2, it will be square root. If it's 3, it will be cube root. If it's 4, it will be fourth root. So that's how it works. Do a root of the denominator and your base is inside and you're done, right? But if your numerator isn't 1, right? You're still going to do a root of your denominator. So it is root b, right? Your x inside. And here you put your a as the power outside. That's how it works. So let's take examples of both. Example. Our first example is, say, 4 raised to the power of half. Remember, the numerator is 1. So all you need to do is do a square root because the denominator is 2. So your answer becomes the square root of 4. And the square root of 4 is 2. And you're done. But just imagine that you have, say, Another example, 64 raised to the power of 2 over 3. There's another example. This one is our first example. This is our second example. So if you have something like this, remember, you check the numerator. In this case, the numerator isn't 1. It is 2. But the denominator is 3. And remember that it is the denominator that goes to the root. So this is cube root of 64. Then you put that in a bracket and square your answer because numerator is 2. Okay, so what is the cube root of 64? Cube root of 64 is 4 because 4 times 4 is 16 times another 4 is 64, right? 4 times 4 times 4. So 4 is the cube root of 64. But remember, you're squaring it. 4 square is the same as 4 times 4, and that is 16. So final answer is 16, and you're done. So this is how to use the sixth law of indices that is divided into two parts. One with 1 as the numerator of your fractional index and the other with a number bigger than 1 as the numerator of your fractional index. This video captured all the laws of indices. Stay tuned to the next video when we'll be solving problems on indices and how to go about it. Thank you for watching.